So in this lecture we will see the likelihood computation using a given hidden Markov model. So likelihood computation is done with the help of the forward algorithm, and this forward algorithm actually computes recursively the probabilities of observations, and then one by one it proceeds to the states and calculates the observation probabilities with the help of previous state probabilities, previous observation probabilities. So what is the likelihood problem? The problem is given an hidden Markov model, say y is equal to a comma b. So we have these two matrices and an observation sequence O. Determine the likelihood P O given y. Right, so this is the objective likelihood computation. So we call this P O given y as likelihood, because likelihood is actually the estimate of some large number of probabilities. So that's we call it as a likelihood. So for example, given an ice cream eating HMM, what is the probability of 313? So let me again briefly tell you about the ice cream eating HMM. Ice cream eating HMM is actually predicting the weather, that is hot and cold, on the number of ice creams sold on that day. So in this case, the first one is day 1 is 3, day 2 is 1, and day 3 is 3. So on the first day 3 ice creams are sold, on the second day 1 ice cream is sold, and the third day 3 ice creams are sold, right? So these 313 are actually the observations, and the states are hot and cold, right? So for a simple Markov chain where we don't have any hidden states, that means in case of simple change we have only these observations are represented as states, then we can simply calculate the probabilities of the sequence, that is P of 3 multiplied by P of 1 given 3 multiplied by P of 3 given 1, and so on, and then we can calculate the likelihood of this sequence of observations. However, the problem with the hidden Markov model is that we know the observations but we don't know the sequence of states. So the problem is that the problem with hidden states is that we don't know the underlying sequence of states. Right. So now we need to make some kind of the calculations based on some assumptions. So what we can assume is that we can have the probability or the likelihood of this sequence can be calculated on the possible sequence of states and multiplying them with their weight of the probabilities. Okay, so we can write it as given the set of states q is equal to q0 q1 dot 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 qt and observations is equal to o1 comma o2 dot 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 ot. So the likelihood of observation sequence with respect to states, the likelihood of observations given states, we all know it is given as P of O given Q, that is equal to product of I is equal to 1 to T for all the time steps, P of OI given QI. So P of, as an example, P of 313 given hot, cold can be calculated as P of 3 given hot dot P of 1 given hot dot P of 3 given cold. Right, so we just given an example here, but we actually don't know the sequence of this hot, cold or whatever it is. So we need to compute the probability P of O comma Q. So here we had calculated, we know how to calculate the P of O given Q. So P of O comma Q is actually the P probability, joint probability of the observations as well as the states. So that can be written as P of O given Q multiplied by P of Q, right? And which can be written as product of I is equal to 1 to T P of OI given QI, and it will be multiplied by the product of P of QI given QI minus 1. Now this is incorporating the information about the states as well, and this is also I is equal to 1 to T. So as an example here, proceeding with the same example, P of 313 comma hot hot, cold can be written as P of hot given start dot P of hot given hot dot 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 all these states, then it will be multiplied by P of observation, that is 3 given hot dot P of 1 given hot, and so on, right? And we know that for a joint probability, when we need to calculate the marginal probability, that is for P of A given B, we have a probability of P of A given B, we can calculate P of A as summation on B, right? So that means if this is the table, this is the probability table of A and B, right? So we need to just find the summation on B towards this side. So in this way we will get two values here, right? Suppose this is 0 and 1, and this is suppose small a, b, c, d. So I will get a probability of A, probability for A is equal to 0 and probability for A is equal to 1. So I will get two probabilities here. So this will be P of A, right? Similarly, we can apply the same thing here. We can get P of so we get P of